Hi, everyone, and thanks for tuning in to our notes today on least common multiple. Believe it or not, least common multiple is something you've been doing since elementary school, but I want to review it. I actually want to go all the way back to elementary school for a short review, and then I'm going to show you how we use least common multiple here in Algebra 1. So we're going to be adding some x's and y's and letters into our LCMs, but it's not that much harder than what you did in elementary school. So before we start into our notes here, I actually want to do sort of a mini lesson. I'm just going to call this a mini lesson. You could actually write this on the back of your note sheet if you'd like to. So I just want to review what an LCM truly is, a least common multiple. The reason we need it in mathematics is for something like this. Say we were adding 2/5 to 4/7. Okay. Now I know and you know that thanks to the capability of your TI-84, you can do your alpha y equals numerator over a denominator and add 2/5 plus 4/7 without even really thinking. All that proves is that you can type, and boom, you get, what do I get there? 34/35. So you can do that quite easily. But let's not forget why the calculator's spitting that out. What's actually happening? Well, what's happening is you can't add fractions unless you have a common denominator. Common denominator, which is something like two words I throw around pretty frequently. Common denominator, I'm trying to talk and spell at the same time, really is the least common multiple of the denominators at hand. So to get a common denominator, you find the least common multiple. Well, what's that? Well, think about what the word multiples mean. Let's look at the multiples of 5. Well, the multiples of 5 are 5, 10, 15, 20, 25, 30. I could do this forever. 35, 40, 45, 50. I'm just going to put a ... to signify that can keep going on. And my multiples of 7 are 7, 14, 21, 28, 35, 42, 49, ... So when you list the multiples out, what you want to look for is the lowest number they have in common. Lowest in common of the multiples. So let's look. Let's scan. Do you see it? I do. 35. The first number they have in common is 35. This is the least common multiple of a 5 and a 7. Simple. So what ends up happening is you rewrite your fractions up here as the sum of two fractions with a common denominator of 35. And so to compensate here for what just happened, you have to multiply this 5 by 7, because 7 times 5 is 35. And you have to multiply this 7 by 5, because 7 times 5 is 35. Whatever you do to the bottom to keep balance, you must do to the top. So I multiplied 5 by 7, so I must multiply 2 by 7, and that gives me 14. And I multiplied 7 by 5, so I have to multiply 4 by 5 to give me 20. And now, since I have a common denominator, I can add my numerators together, put it all over the common denominator, and 14 plus 20 is, of course, 34. And bingo, we match. So that's what alpha y equals is doing on the calculator, so let's not forget that. Okay, so that was elementary school. So how does this come into Algebra 1? Well, I'm going to add some variables into the mix. So we're going to take the same problem, okay, but now instead of 2/5, we're going to put 2/5x. And instead of 4/7, we're going to put 4/7x to the third. Okay? How do you add these fractions? Well, we need a common denominator. So we need a least common multiple. Now, the good news is the coefficient 5 and 7, you still find the least common multiple of those two the same way you did here. Now, I want to offer this up. You can do this by hand like I just did, but that can get a little cumbersome if your numbers downstairs here are high, or if their multiple comes way out to the right. So there is something I want to show you on your TI. Some of you may have seen it already because of Alex. There is a function on the TI that will allow you to find the LCM of numbers. It won't do variables, but it will do your numbers, and that can speed the process up a little bit. What you press is the math key here, which is right here under alpha, this math key. Hit that, and then you're going to want to highlight num, so you're going to arrow off to the right, and you're going to come all the way down to number 8. If you look at number 8, right there it is, LCM. So you hit enter, and you type in your two coefficients, so 5 and 7, and you separate those with a comma. So we're going to go 5, comma, 7. And I close parentheses and hit enter, and you'll see it'll spit that 35 right out. And I'm okay with you using this so long as you know where the calculator's getting that. Okay, so then we know that part of our common denominator is 35. So let's get that started. Okay, and just a side note, if you ever have to find an LCM and you have more than more than two numbers that you're trying to find, the calculator can only handle 2 at a time. So this is just an aside. Say you were trying to find the LCM of a 5, a 7, and let's say a 10. And there was this third number. Of course, you could just go out until you found the commonality. The way you would do it on the TI with 3 numbers is you would start with the first 2, just like I already did, 35. So since the LCM of these 2 is 35, you would then just do this again, math num number 8, and you would do 35, comma, and then the next piece, 10. And so you see you get 70. So the LCM of all 3 of these, if you're going to use the TI-84, is 70. And you can do however many you want. If you had more, you would just keep adding on, and then you would use the 70 with the next number, and so on and so forth. So that's just food for thought. Okay, so coming back here, we've got the 35. Now we got to deal with these x's. So here's the thing, guys. X to the third. We've got to come up with the LCM here. Now, let's think about this. If they have to have a common denominator, this fraction right here already has 3 x's. Like, we can't change that. We can't get rid of these because it already has them. This fraction, however, we can grow an x to become x to the third. Okay, we can't strip away from this one because it already has 3 x's. But we can add x's or grow this to look more like this one. Okay, so I wouldn't make my common denominator any more than an x cubed. I would leave that. See how it's like whatever is the bigger exponent, we can just leave that. What we'll do then is, since they have to match, what we'll do is we'll multiply. Can you think of what we would multiply bottom and top by to grow an x to become an x to the third? You already have 1 x. You need 2 more. So if you multiply the bottom, 5x times x squared is 35x to the third. 2 times x squared is just 2x squared. This fraction here, we already had x cubed, so we need not multiply by anything. We can just bring the 4 along. And so the answer to this problem then would be, everything would be over the new common denominator, 35x cubed, and we will add the numerators, 2x squared plus 4. Final answer. Okay, so that's the thought that goes into it. Now, what a lot of students will do moving forward with LCM is they'll just say, okay, look, I'm finding an LCM. This is a multiple. It's a common denominator. So I have to keep the bigger exponent. So the LCM will always contain the highest exponent on any of the variables that were given. So keep that in mind as we work through the notes. So now the notes become pretty simple. So it says, and I just reminded you of a few things here. One thing I said here is that you can easily find the numeric part of a least common multiple on your TI-84 by following these steps. We've already gone over them. You press math, num, number 8, and then you type in first number, comma, second number. To find the variable part of your LCM, so a variable part of an LCM, just take the highest exponent on each variable. And I hope that you understand why that's happening. So once we got all that, we can go through these 3 examples quite easily. So check this out. Let me clear this. For the 20 and the 54, which are the numeric parts here, I'm just going to do math, num, 8, 20, comma, 54. And I'm getting 540. Okay, 540. Now, the variables. We got an x squared, we got an x cubed. We can grow an x squared to become an x cubed, so the common part will be the bigger exponent, x cubed. Now let's look at our y's. Y versus y to the 4th. We can grow a y into a y to the 4th, so we're going to take our higher y to the 4th. Final answer. See how easy that is? Let's go to the next one. Find the least common multiple. Okay, 4, 28, and 42. So math, num, 8, 28, comma, 42. I'm getting 84. Sorry for the glare. And the variable part. We've got an x squared, x to the 6th, common denominator, think common denominator. We can grow an x squared to become an x to the 6th, so this is what they can have in common. Okay? And last but not least, one more. We've got a 60 and a 210. So, math, num, 8, 60, comma, 210. Looks like 420, numerical part. And I'm going to take the higher exponent, x to the 4th versus x to the 5th. Higher one is x to the 5th. Now this gets interesting. Here we have a y, and on this one we have nothing, no y. But we can grow no y into a y because we can just multiply by y. So the bigger y term here is just a y because this has nothing. So we'll include that y. And now we look at the z's, z squared. Well, z squared versus nothing, well, we can grow nothing into a z squared by multiplying by z squared. So I'm going to say z squared. This is what this would be like. Say, just check this out for a second and we'll be done. Say these were denominators of fractions. So here, on this one, we had something over 60 x to the 4th y. And here we had something over 210 x to the 5th z to the 2nd. See, if we make our new denominator 420 x to the 5th y z to the 2nd for both of these, I'm just taking the answer from up above. 420, x to the 5th, y, z to the 2nd. You just have to make sure you can grow each of these denominators into the new denominator. And you can. So what would you multiply 60 by to get 420? So what am I multiplying 60 by to get 420? Well, let's take 420 divided by 60, 7. Okay? So 7. And then how do you grow an x to the 4th to an x to the 5th? Well, you multiply by x. Y, you don't have to grow that at all. And how do you grow a z squared? You multiply by z squared. So that's how that becomes that. The second one, if you take 420 divided by 210, you get 2. So I would multiply by a 2. I'm sorry, not down here. Up here, I would multiply by a 2. And then how do I make an x to the 5th and x to the 5th? Well, multiply by 1, it's already there. Z squared, got it. But I don't have a y, but I can easily grow it by just multiplying by it. So you see that both of the original denominators can grow into the new denominator. So that's how you find an LCM. Alrighty, thanks for watching.